The Nava 38 sports fishing boat, shown here under construction in Vancouver, Canada, has a built-in live well within its cockpit. The cockpit module is temporarily lifted out of the hull to conduct this test. The live well system will be used for keeping not only bait fish, but crabs, oysters, scallops, sea urchins, etc., so that a convenient meal of fresh seafood can be had at any time. The system has several sophisticated features that need to be checked before the boat's final assembly. The inner surface of the boat's transom is intended to form the tank's aft wall, and the deck gunnel forms the forward upper wall. So for this test, temporary walls were installed. The curved acrylic window and all plumbing have been temporarily installed as well. Access to the tank will be through a hinged and latched lid atop the boat's transom. The lid will also have a seal to prevent water from sloshing out. All fittings within the tank are recessed to prevent injury to the bait, as can be seen with this waterproof LED light, one on either side for night viewing. The incoming seawater enters through this row of recessed vertical holes to establish a gentle counterclockwise circulation. The bottom holes are angled up, intending to have an upwelling effect to scavenge toxic fish waste from the bottom and suspend it so it can eventually be discharged overboard through the upper drain. The tank can be emptied completely through the recessed bottom drain and by opening a valve. The inflowing water and discharge water volumes can both be throttled by means of valves to adjust or balance their flows. This will be important to create a pressurized tank by having slightly more water in than out to reduce the sloshing effect within the live well, which otherwise may injure the contents. Access to the valves is through this door adjacent to the live well. Extended valve handles were made that will be permanently connected to the valves for convenient adjustments. For the test, the 200-liter drum was placed in the hull as a water source, with the water pickup installed approximately at the same height as will be the finished pickup to properly simulate the pump's head pressure. A SureFlow brand 1100 gallon per hour mag drive bait entry pump was chosen. The inlet water velocity is quite significant at the unthrottled maximum pump output of 27 liters per minute, or 7 US gallons per minute. It took 8 minutes to fill the 220-liter tank, which indicates that every 8 minutes a replacement or turn of the water will occur, which is apparently an acceptable rate for maintaining fish in our cool northwest waters. Because the tank's water is continually being changed with new, an upper level drain is needed to discharge the old water overboard. Blue food coloring was introduced at the pump's inlet to see what could be learned about circulation patterns. The upwelling effect of the up-angled inlet holes seems evident here. The dye is quickly carried and concentrates at the opposite end, then slowly gets pushed back towards the inlet, being drawn by a current across the bottom. Note the lighter colored area at the inlet end, then at the opposite end as the concentration of dye moves back across the tank. The entire tank quickly becomes thoroughly blended. With the inlet valve fully open and the drain fully closed, small pieces of saturated autumn leaf debris were introduced to permit better study of what's going on throughout the water column and its circulation characteristics as the leaves become suspended. An upwelling effect can be seen in this corner as some particles become drawn out the upper discharge while others find their way back into the water inlet jets and are pushed down the tank. This volume is at full pump output of 27 liters per minute with no throttling of valves. About halfway down the back wall, some deflection occurs, pushing the debris into the center of the tank, while other particles are pushed to the opposite end where they fall out and then are drawn across the bottom by quite a fast current back towards the inlet. In the corner on the right, just before the water jets, there appears to be a zone of slower movement. In general, at this full volume setting, there's much water movement throughout the tank. It's faster and more random. Conclusions from these tests are the live well seems capable of plenty of water circulation with what appears to be decent ability to move debris such as fish waste out the discharge. These features will be beneficial for maintaining shellfish, but currents may be somewhat random with possible areas of slower movement. Whether this is to a degree that is unsatisfactory for keeping bait fish is not known.